Welcome to Azure Skåne and our first meeting here in the city of Helsingborg. Yeah, right. And what is Azure Skåne? Well, we are one of the 3 big user groups in Sweden for people who are interested in everything Azure. So it's about learning new things, and hopefully you will learn something from today's presentations. It's about networking, meeting great people like you, and it's, of course, not the least important, it's about having fun. And we are now over 800 members, as you can see here. But for some reason they are not able to find their way here. So, well, it is Corona times and it's a new city and everything. We had 20 persons signed up, which is still much lower than usual. So yeah, let's see if more people appear a bit later here. And also you're all welcome here, regardless of your previous experience of Azure. So this is both for beginners as well as experts. And Azure Skåne, it is run by volunteers. It is me, Johan Åhlén, and I have been using Azure since really the very beginning. I've been working with databases and data management since something like 25 years, both for some very large companies and some smaller companies. And I run my own company right now. And then there is Magnus Lindhe, and Magnus is a Microsoft Regional Director. And he has done quite a few presentations on Azure, so you might have seen his name and his face somewhere, maybe attended one of his workshops or something like that. And then we have Mikael Jonsson. Maybe you can say something yourself. Hi.
Yeah.
I guess you have to get down here.
Azure.
Okay. Yeah.
Visible to the camera. There.
Yes, here it is.
Oh, there's a camera. Yeah. So my name is Michael, I'm also part of the team. Been working with Azure since early days. Like it a lot, it's always interesting. It's going to be really fun to listen to this presentation.
Yeah. And then there is also Robin Karlsson, and he's a consultant working with Dynamics and Azure. So, first a very big thank you to our host here tonight, Helsingborg Works. Could you say a few words, Jeanette?
Sure. So I'm Jeanette, and I'm a unit manager here at the digitalization department or IT department of Helsingborg Stad, city of Helsingborg. And you are here at this place today, this staircase, which is a meeting place in the city for all the departments to come as, being an incubator or accelerator for the city, to engage with innovations, prototyping, piloting, and so on. Learning about design methods and so on for creative ideas. And also here behind the screen is also a team called H22, which is the team also preparing for the City Expo, as you might have heard, that we will be having a big, huge City Expo for the new city of Helsingborg. And we are the city who wants to be the innovative and sustainable city. So I'm manager for the data factory, as we call it in Swedish, and so you will be meeting some of my team members here today. Yeah.
Thank you, Jeanette. And anything you see here tonight, you are very welcome to take pictures, tweet about it, write about it. There are no secrets here. So I would say rather the opposite. It's very nice if we can get heard. So Microsoft, they are monitoring Twitter 24 hours a day, and it's very nice if they can see a spike in Twitter traffic about Azure here in South Sweden today. So very welcome to share anything. And Microsoft, they also have built a blockchain. Have you heard about that before? They call it the digital badgers. So this is like bitcoins, but instead of getting coins, you get kind of badges for doing things. So you can see here you have a community hero, mentor, maker. So if you make something really cool on Azure, you can be nominated for a maker badge. And they are limited in numbers, so in total there will only be 2,000 in the whole world. So it's nice to be awarded one of these. And to get them you need something like a blockchain wallet. And actually tonight you all get a badge, a learner badge. So all you need to do is that you need a wallet, and then you need to scan this QR code here. And we will help you during the break set this up if you want to get help. But this will get you a learner badge, and we have been told that if you show this to Microsoft at a conference or something, you will be rewarded. So it is good to collect these and show that you have learned a lot about Azure. Great. In November we will have our next event, and that will be on 17th of November about Azure DevOps for the IT Pro with Barbara Forbes. She's a Microsoft MVP and very interesting speaker, so I can really recommend this. And there will be more details in an invitation later coming up. So with that, it's time to start the first presentation about AI-assisted parking space finder. And then we take a break, refreshments. And during that time you can get help with getting a digital badge. And then there will be TB Kovaci presenting GitHub Actions. So, welcome on stage Leo Schnede.
Leo is our, is our lead in parking in Helsingborg. And you can see I'm not Leo. Unfortunately, Leo could not be here today. He was double booked, so he sent me the slides and we went through it this morning. So I hope to be able to walk you through it. And if you have detailed questions, I will try to answer them. Otherwise, we take it with us and get back to you later on. So when it comes to parking, a little bit background. What is the problem? Studies shows that in rush hour in the central city, about 30% of the traffic is related to people trying to find parking lot. And also studies shows that in a parking area, people perceive that it's full when it's actually is 15% left. So what does this lead to? It leads to excessive CO2 emission, inefficient use of public space. We always have to plan for overcapacity. And also, of course, is driving around in rush hour trying to find parking. It's a lot of stress. It's not that good life quality. So, with this, we have set some goals within the municipality. We're going to try to reduce the traffic congestions with 50% until May next year. And also, if we can reduce the traffic congestion, we will of course reduce the CO2 emission. We haven't set a target here yet. We have to define it later on also. And also, of course, increase customer satisfaction, which is, of course, also related to that you find a parking spot very quick. You know where to park. And if you remember that I said that people perceive that the parking is full already at 85% occupational, this will result in a lot of cost also for us. Then we have to overplan when we plan a new parking area. So this is something that we need to solve. And also some significant factors that we know are connected to how the customers choose the parking. how far it is from my final destination, how long do I have to walk, how much it costs. Maybe if you're just going to park for half an hour, it doesn't matter that much, but for half a day, it could definitely have impact of what you select. And weather, of course. If it's really sunny, maybe you don't mind take a little bit longer walk, but if it rains, you want to be close to a final destination. So based on this, we have tried to solve the issue by AI, predictive algorithm to find a free parking spot already before you arrive. So with that, I leave the word to you.
Thank you, Magnus. So I will not show any PowerPoints. I think it would be more interesting to see things in Azure instead. So let's go over to my demos.
So you mean it works?
Yes, no, it's all fake, you know. No, as Magnus said, we had the parking manager here in Helsingborg city. He's giving us a task to build something that can predict and estimate the parking availability at any time. Well, not too well. Yeah, can predict in the future. Of course, you can't predict years ahead. You need to have some kind of time limit. So we can predict a few days in the future how the parking situation will be in the city. And we have built something that could be used by an end user. So this is now a website. You can actually visit it yourselves. As you can see, it's azurewebsites.net. What does that mean? It's being run as an Azure web app, of course. And it's called Parkeringsprediktion OBG. Sorry, it's very hard to say in English, but yeah. You see the address here. If you're interested in trying it, it works on you can use it from mobile phone also. It's mobile friendly. And here you can type any address in the city. So, which address should we try? This is our current address right now, but again, we can try any address. Do we have any suggestions on it?
That's the hardest one anyway to find, so...
Why did you park your car?
Yeah. Okay, if we take this address, Drottninggatan 14, that is our current address right here, right now. And then we choose a time, and right now is, if you click here, you see it's pretty good parking situation right now, because it's after work time. But if we choose tomorrow instead, Tuesday, and let's say tomorrow at 9, and search, you see the parking situation will be quite different. So this gives you search results which you can sort by the distance, if that's the most important, you don't want to walk, or if it's about the cost, or if it's about category, if it's outdoors or indoor parking, or parking space availability. And then you can click on these. So we can click on one of the parking places, and it will scroll it on the map. So this is now an interactive map, where you can see with colors the availability. This is the closest one. You see it's yellow tomorrow morning at 9. If you look at, let's say, 7 in the morning instead, it will change to green. And if you click on it, you will get some details about the category, the cost, and how much occupancy, how much of it is already being used. And right now, you can see it's a bit limited list here, and that's because we have included only the fixed parking places. We haven't included the street parking. So that's the next step to make this really useful, because either you can park in a parking house or these big parking places, or you could park just along the street. The street is a little bit more challenging to do because it means you have to collect from more data sources. Because the streets, they have now started to get connected parking meters. So actually that they are internet connected, so you can collect data from parking meters. And also you need to collect data from parking apps. But this is supposed to be a demo, and it could be used also for building something, showing it inside an app, parking app. So how many of you use parking apps? Yeah, most of you. So wouldn't it be nice to have something in, let's say, Easy Park or Parks that we can just help you find the nearest parking place? So that's kind of integrations we can do here with the API. Yes? No question? No? Sorry. Okay, no problems. Also we added, so we can check the predictions, the quality of the predictions. Because, as I said, we could be making all this up. But if you compare them to the real parking situation, what do you think? Does it give us any good results or not? Well, let's see. So we just pick one of these areas, like this is now the closest parking place. And here's now the blue line is the real parking usage, and the green one is the predicted values. So it's not too bad.
Is by hour or what's the scale down there?
The scale.
Yeah. No, the one the
down here.
Yeah.
It is. You can say easy to see the days here, because I mean, during daytime it goes up, and then during night it goes down.
Okay.
So yeah, I haven't spent any time on formatting it, so it's a bit hard to read.
Every dot is 1 hour. It's at one certain hour or half an hour.
Every dot is every 15 minutes.
Oh, okay.
So the resolution of the system is right now it is 15 minutes. It could be increased, of course. It's just we had to make some kind of resolution. We thought that 15 minutes, then things they don't change too much within 15 minutes. So we thought that was a good resolution for the system. And you can easily see these are the weekdays, and here is obviously the weekend. It's a different pattern. And we can check also for other parking places, so it's not just this Sundsvallsgaraget. Here's at the central station, the parking situation. And it is AI based, and this AI is retrained every day, so it gets better and better. And now the question is, what kind of data do we use for the AI? What do you think is input?
The money you get from the parking meters.
Yeah, well, it's actually not connected to parking meters right now. It is connected to the parking houses, etc. They have some kind of measuring system every time a car passes. It's a magnetic thing in the ground, so it can measure every time car passes that line. So that is the way to measure how many cars pass in or out. And so that is one of the data sources. And that gives us all the historical data. So we use that to get the blue line that comes from that measuring system. But to predict, you need some kind of data about the future. And we started thinking, what kind of data do we need to make a good prediction? And Magnus already mentioned some things like weather, of course. So how do we collect weather? How do we know the weather in the future?
We never know.
We never know. Well, we have to guess it somehow. So, and who are guessing the weather in the future? SMHI, yes, that's right. So we have connected to SMHI and their API. So every hour we get a new weather forecast, and we use that for the prediction. So the prediction is updated every hour, because then we have even more actual data from the parking places. We have a new weather data. Then also what other factors could affect the parking? Events, absolutely. So we collect event data. So luckily for us, there was already some people who built a system where they had collected all events in Helsingborg city. So we connect to their API and we get information about all events that are being run. The problem with that is that we can get the name of the events and the location and all that, but we don't know how popular the events are. Because we can see event names and we can see the name of the organizer, but it's very hard to go from there to see if is this a big event that will attract hundreds of people, or is this a very small event. And that is something you can train the AI on, of course. So it can learn from, I would say probably the organizer is the best indicator of how many people will, how much is the impact of this event. So there is an API for events, yes, and we use it. And then there are other things like school days. So we have collected information in advance, like when does schools start? Because in the summer when there are no schools open, it will of course have an impact on parking place near the schools. Big special holidays like Christmas or New Year's Eve, etc. All of that is also entered into calendar. So all of this is being used as input for our prediction AI. And if we look at the reason behind this project, why did we start this? I would say there are two things here. First of all, there was this Leo Snede, who is not here today, but he's kind of lord of empty spaces in the city, parking manager, lord of empty spaces. And he wanted to do this, to see if something can be built that can improve the parking situation in the city. And also at the same time we are working with something that is called the Data Factory, which is, Jeanette is the manager of that. And we wanted to do proof of concept, building a data warehouse, data marts in Azure. And then we said, why not build this on parking data and solve something for Leo and at the same time do a very interesting proof of concept. So that's how this project started. So we have a couple of data sources, which is again the measuring system that measures parkings and also weather data, etc. So we built a data warehouse, and I will show you this in this presentation, what we have built. So any questions so far? Yes?
So I think it's a tough task to start predicting stuff on historical data, considering events today doesn't look the same.
Yes, absolutely. You're completely correct about that. It's events obviously have the impact of events has changed a lot since February this year. So it was that was very tricky for an AI to actually we have excluded the events because it was not useful. The other part here was that historical event data had not been saved, so we only could get event data from a certain point of time. So that is one of the lessons learned here, that data is valuable. Save your data, keep your data. Don't delete it because you don't see any usage for it right now, because you might see...
Put it in Excel.
Yeah, whatever. No, put it in Azure Data Lake, something like that. Whatever. Don't delete your data because you don't see any usage for it right now. So what we built now is, as I said, we're collecting data from a couple of sources. So first we have a data lake. Do you know what the data lake is? It is kind of it is blob storage in Azure. The only difference compared to before is that it used something called how do I pronounce it? Hierarchical namespaces. And that means it supports kind of directory structure like a file system. So if you don't have it, directories are a bit more trickier and works different. So it's better. Yeah, it's nicer to work with. So we use that. So it is more or less like a file share, where you can put blobs. Blobs are like files. And in here, we create a couple of containers for our data. First, we have the raw container, which is where we have input data. And this is now the event data, and I can show you here's we receive the events in JSON format. So I can open them here and edit. This is the input we receive from that API. And it looks maybe a bit complicated here, but it is structured JSON data, so we can handle it. But we need to extract the interesting part from here, because 90% of this is things that are not interesting to our prediction algorithm. So we need to extract the interesting things like date, time, place, location, that kind of things. Then we have something we call grunddata in Swedish, which is like basic data. So, sorry, let me go back here. Grunddata. So here's now the parking configuration. And parking configuration, that tells us the parking places, it tells us the geographic location, it contains the pricing for them, opening hours, the category if it's outdoors or indoors, etc. And that's placed in an Excel file. So if you want to open it here, you'll just see a lot of rubbish. So if you wish to edit it, you need to download it and open it locally on your computer in Excel instead. And then you can upload it to make changes. So do you need to see it, or should we just go on? Yeah, just go on. Then there is the calendar, which I said that contains information about special days like Christmas and New Year's Eve, because they of course have an impact on the prediction. It contains time for when schools are open, etc. And then we have history. So because the SMHI API didn't give us a very long history, so we imported manually a longer bit of history for the AI training. And then we use the other data sources. Many of them write directly to SQL database. So if you look at the resources we have here, it's this data lake storage account, and then it's we have two SQL databases. So when we import structured data, in many cases it's better to write directly to the SQL database. We don't need to write it to data lake first and then SQL database. That's just some extra steps to do that. So what do we use for transferring data, for integrations? Which tool? What do you think? Since this is built on Azure, there's one tool in Azure, yes?
Data Factory.
The Azure Data Factory, of course. That's what we use. So,
a question there.
Yes?
So the SMHI APIs and the calendar from Helsingborgsstad, etc.
Yes. Event calendar.
Fetching that, how do you actually get that data from
Yes,
those
and
sources?
that's where we use the Azure Data Factory
Okay.
to get the data. So we can have a look here at the Azure Data Factory. And it, first of all, we have some linked services, linked services that are places you can connect to. And we have this infra control, that's where we get the actual parking data. And then we have SMHI, and this is the forecast API at SMHI. And then they have their observations API. So there are two APIs. And then for the event data, it goes through the data lake. And actually we wanted to test another ETL tool, so that's why it's not visible here. And then we have the SQL databases. But we can take a look at the pipelines. So here's the actual pipeline for getting data from SMHI. So we can see here first it prepares, it truncates the tables so they are empty, so we can start loading data in the SQL database. And then it connects, we use copy data tasks. That is a very useful task in Azure Data Factory. You can do a lot with it. So we try to use that as much as possible. Then there's a data flow task also. But we try to use this as much as possible, because it can also do not so bad functionality around transformations. So actually we can look at the data set here. So then we have SMHI, and then there's one data set for rain, for instance. So there's a base address here, which is the base address for this API at SMHI. And then there's the specific API call that we use to get this specific data. We want to get rain data. And this is the station we're reading. So we're reading a station here in Helsingborg area, because we're not interested in the weather in Stockholm or something. That's not important for our predictions. So here it says 7. 7, that is the parameter number for rain. And then here's the station number for, it's called Helsingborg A. I don't know where it's located here, but somewhere in the city is Helsingborg A, which we use. And they give us a JSON result back, which we can write to our database easily. That's being done here in the in these tasks. So the source, that's this API, and it's being written to a database table, and then we can do mappings. So from the JSON we do a mapping that transforms the JSON to table columns. So this is a very nice feature of Azure Data Factories. It's very easy to take a JSON input and turn it into a table that you can write to a database. So it's very nice to do this without any coding. You just need to do some mapping here, say which columns you're interested in. And then this is now being run periodically. As I said, we can look at monitoring here, and you will see SMHI here. It was run at 5:25 p.m. and we can see it took 12 seconds to run it, and it was succeeded. So you get a log of everything that's happening in Data Factory. That's very nice. So you can see this one is run every hour at that time. That is because that is a time when they are finished with a forecast. So it's no meaning to do another call before they have a new forecast. So that's why there's no meaning to call them again until after 1 hour. While the parking situation, you see, we try to get information every 15 minutes because that's our resolution. And then we have also this one, which is taking data from data warehouse to data mart. So we're divided the data warehouse, which contains a lot of data, and data mart, which is specific data for this prediction. One of the difficulties, if you if you've used Azure Data Factory, it's very easy to use for REST APIs. So if I create a new API here, like this, you see this list of possible connectors. It's quite a lot of them. And this is now where you can choose REST API. But one of our APIs was a bit more difficult because it was a SOAP API instead. And yeah, it's not only Azure Data Factory that has problems with SOAP. SOAP is a more complicated protocol, so they don't have any SOAP connector. So how can you connect from Azure Data Factory to SOAP connector, the SOAP API? Pardon?
Enterprise integrations.
Yeah, maybe that is one way, but the easier way.
Logic app or
I haven't tried it that way, but I want to do it only from in here, as easy and cheap as possible. And that's one way to do it, and that is to use the HTTP connector, this one. Because that's a very, very generic connector. And you have to do things very manually. And so basically you have to understand the SOAP protocol.
But in other words, you get no validation, nothing. You just
no, you don't get any validation.
You handpick the stuff that you need.
Yeah, but SOAP gives you a XML output, and it validates that it's that the XML is okay.
Yeah.
And then you have to handle that XML, and you can handle it through the built-in mapping in Azure Data Factory. So that's very easy to do.
Mm-hmm.
So, but you need to understand the SOAP protocol to do this.
Yeah.
There are some helper tools available for SOAP that you can use for getting started. So, but SOAP is a bit more difficult. But apart from that, there was really nothing special building this in Azure Data Factory. And then we have these SQL databases. So, because as I said, we wanted to build a data warehouse, and now this is a super small data warehouse compared to many others, of course. But still, it's like you have tables with 1 million rows if we look at weather data, etc. Because if you take every hour for many years, it starts adding up. And in the data warehouse, we have used stored procedures, of course, and tables. So the structure is like this. Sorry. We import data in a scheme that we call raw. So raw, that is unprocessed data. It can have bad data quality, and it definitely has in some cases, because these data sources, they are not 100% reliable. So sometimes it's missing data, sometimes it's very strange values coming in. And then the next one is control, which is data that has passed through some kind of data quality control. And then we have transformed data types. So if you look at the SMHI, for instance, we have rain observations. If you look at the data types here, notice it's all just varchar data, because that's the way we get it. And we have the date, it's in a bit strange format. So one thing is to, when we send it to control, we need to, let me see here. For instance, we need to turn the date into date time field instead, because that's much nicer to handle. And also, of course, the value here, it's a decimal value. They give you like, could be something like 1.5 degrees or so. So they have one decimal in that value. And they have something called quality. So sometimes they can tell you this measure, it had a bad data quality, they tell you themselves. So you have to take that into account. And staging key, because if we wanted to run this in multiple cities, we could, of course, record data from different stations. So that is what happens. And then we have a flag if the data is valid or not, if it should be included. And then it goes into the third stage, which is the storage. And storage, here we have it. Then rain and temperature, they are placed together in the same table. It's much easier to handle it that way. Then you don't need to keep joining tables. And you see, we skip all the unnecessary columns here, so we just have the useful data. And this one, storage, it's getting stored, while the other ones, they get truncated. So when we start updating things, we truncate the other tables, but storage, that remains in the database. So this table just grows bigger and bigger. And these tables, they have like a million rows right now, which is not, that's not a big data warehouse, but it's a million rows, it's not that small. And as I said, we had some problems with bad data quality. So then we have special store procedures for that. So we have this one, in Swedish, städa dålig datakvalitet, you know. Yeah. If you're Swedish, you understand what it is doing. So it's clean up bad data quality. Because sometimes the system told us there were 500,000 cars parked, and that would completely throw off our AI if it got values like that, because then it would know we need to have some clean and good data for the training. We don't want it to predict that we have 500,000 cars parked. These databases, they are, as I said, they are of course Azure. Everything is 100% in Azure here. So we are running them, and all of these solutions is running at quite low cost, I can tell you. So the SQL databases, if we look at them, we can look at this one first here. You see it's running on the basic level, which costs how much approximately per month?
$12 or 12 euros or something.
Oh, less than that.
The basic.
The basic level. Let's see what it costs us.
You don't pay anything, so I don't know.
No.
43, $4.
43
4 euros, yeah.
40, like 4 euros per month. That's the cost for that.
Good. Municipality.
Yes. So we're saving a lot of money here. And it will be interesting, you can guess later what this whole solution costs per day in running it in Azure. But so this is what, and we have 2 databases, so we have to pay twice that, of course. But actually, even at that level, it is the performance is definitely good enough for running this. There's no, you can see the database utilization here. You see this is a space. You are still under 20% of the cap, and you see this CPU usage. There's just one spike when we do some extra testing or something, but otherwise the CPU level is very low.
I think the standard S0 is $12 per month or something.
Yes, we can actually see that if we go here. Yes, here's the price for standard level.
130.
Yeah, 130 Swedish crowns per month. And of course that one has way better performance than the other one. But it's not necessary for us.
This is, the recommendation is to use that for production purposes.
Of course, yes.
I mean,
so absolutely. So this is not, what I'm showing you right now, it's not sized for production usage. It's definitely not. So in production, definitely at least the standard level. And then we have the AI part. Are you interested in looking into AI? Yes, okay. So let's look into the Azure machine learning. So we have here, let me open it. The way it works is you have something called Machine Learning Studio. That is the way you work with machine learning in Azure. And you can create something called experiments, and you have data sets. So the first step is to upload some data. So we take some data from the SQL databases. If we had to create a data set, what I'm missing here, I would like an option here for taking data directly from the SQL database. It's not possible. So you need to download the data from the database to a file or something, and then you can upload the file in here.
Isn't there any user voice or something that you can, or I think...
I hope so, but I would definitely vote for such a feature.
Okay.
But yeah, anyway, you can download from a database to a file, and then you can upload the file here. And that's what I did. So I uploaded 3 test files with data. And what they contain is something like this. If you click here. So here you can see this is really the input for AI. So it tells you which area. We have area codes, we have names, and these are opening hours during, let's say, non-weekends. And this is Saturday times, and this is Sunday times. And then this is the price per hour, and this is how many hours you are allowed to park in this place. Because of course, if you are allowed to park for 30 days in a row, it can have, of course, some impact compared to if you have only 2 hours maximum parking time. The category, if it's outdoors or if it's indoors in a parking house. This is a reference time of that sample, the date time, and then we can scroll some further. Yeah, this tells you if it's a weekend or not. This is if the schools are open during that day. This is the gymnasium, what to say in English? Yeah, college level, high school. If the high schools are open or not. And this is if it's a red day like Christmas or New Year's Eve. This is if it's lönehelg. You know lönehelg in Sweden? No, that the 25th, that's when a lot of things happen because people get their money, so they go out shopping and spending money. So more people move into the city or around the shops when it's lönehelg. And then you have the rain. This is measured in number of millimeters per hour, so this means that it's 1 millimeter per hour raining. And this is the temperature. It looks high, 62. Because it's not, no, it's not Fahrenheit. It's actually because we don't want the decimal numbers, so we multiply it by 10. So it's actually 6.2 degrees. So. But that's not obvious. But for the AI, it is very good to have integer values. So we want to convert to integer, and the easiest way was to just multiply by 10. And then occupancy, which is how many places are taken. So this is the kind of input we use, and then you can train models, and actually you can use AI for creating other AI here. So Microsoft has something called automated ML or auto ML, yeah. Auto ML. Yeah. So basically, their machine learning helps you build a machine learning solution. So sounds maybe a little bit scary, like Terminator and that kind of things, but that's one of the easiest ways to get started. So you can create an automatic run here. You pick a data set like this one, and then you choose to create a new or existing experiment, the column you want to predict, and compute cluster, which is the compute resources being used. We can take a look at that. I can just show you here. There are 3 kinds of AI models in Azure, or in general. So what is the first one? It's classification, which is when you have categories like yes, no, or you have colors like green, yellow, red or something. So you create AIs that work on categories. But you can also create AIs that work on numbers, that's regression. Or you can create AIs that do some kind of time, something kind of forecasting in time. And what do you think this is? What kind of, where would you put this?
Regression.
Yes, that's actually not a bad idea. It is, I would say both options are possible, regression or time series forecasting. So time series forecasting, it is specially built for predicting the future. And that is very useful for this. But actually, you can do forecasting also with regression. So we started here with time series forecasting, but after doing some exploration here, we found that, okay, let's apply this as a regression model instead. Because regression models can do forecasting also. So the actual model running right now is a regression model. And then you have some settings here, like all the fields, you have to classify them. So area code, yeah, sure, but name, that's not interesting for the AI. If you look at the price, definitely interesting, but it's numeric value. So you have to tell it what are numerical values and what are categorical values, etc. If it's lönehelg or not, that's typical categorical, because it's lönehelg yes or lönehelg no. So you set that up with options. I will not start this now because you can let it spend 1 hour running the training. But what happens then is that you get some output like this. I will show you. Where you get all the models that it has tested for you. So these are the let's say, the AutoML is testing a lot of models with different parameters. And it gives you some kind of score how well they work. So, and you get them sorted in quality order. So you can pick the model that works best for you, like you can take the top one. And then you can deploy it. And then it will be deployed in Azure, so you can connect to it and use it for predictions. Or you can download it locally, and then you get a file, so you can run it locally on your own computer. So models you develop here, you can run them in Azure, or you can run them locally. That's you just choose wherever you want to run them. And you have explanations that tells you the parameter and the influence of different parameters. So you get a bar chart of what is most important to the AI. And you can see the models you have here. You get the list of them, and you can actually upload your own models. You can develop models locally and upload to Azure and run them in Azure also. So here are some of the standard formats supported. So you can use like TensorFlow, if you heard about that. That's Google AI platform, Google tools. Or ONNX, that's kind of standard format that's used by many AI platforms. And then you can deploy it and run it in Azure. There's another way to deploy them. So instead of deploying it with a deploy button here, we did it a little bit differently. We used Azure Function instead. So basically you can embed the model in an Azure function and deploy it. It will be same results.
But much cheaper.
Much cheaper, yes. So, because with the Azure function you only pay when it's being used. So while if you deploy here, how do you think they are being run? What happens? They get deployed as containers, like Docker containers. So they will cost you about 10 Swedish crowns per day to run. And it might not be that much money, but you can run them completely free with Azure functions.
Actually, 2 years ago at Build, I seen the first time when they did something similar and they deployed on a Raspberry Pi. I was
Yes.
so, like, you do machine learning, when you think machine learning, you think
Yes.
those big data centers, and they come and say, we can deploy it here. Like, but how big is the model? Like, once you train it, it's up to 200 meg, but not even that. Then have a complete model with, face recognition and all kinds of things. Like,
Yes.
so that's impressive.
Yes, I will show you our model here. If you look, our model is actually stored in the data lake, and it gets retrained every day. And this is the size of the model. You can see it's 38 megabyte in size, the model.
So you can deploy it on a Raspberry Pi.
So I could probably deploy it on a Raspberry Pi, yes. Yes.
You said it gets trained every day, so does it get trained on new data?
Yes, it does. So it
And if you would add a new column also, new data set?
Yes, we could do that also. But there is in the Azure, it's an Azure function that does retraining. So the Azure function, it fetches the latest data.
Have you tried to see if there is any improvement in the, in that? Because you might not get any benefits of retraining it. Like once you got it, it's there. It's the same. Or
Yeah.
maybe
Well.
once a month might be enough.
Yeah. Well, in general, you should always be retraining because people will change their behavior and things will happen. So definitely, in the long run, you need to retrain it.
I'm thinking daily it's a bit of.
But daily, that is very often, absolutely. But training it takes just a few minutes.
Okay.
So, and it's being done by this Azure function. So okay, why not?
Yeah.
So Azure Data Factory is used to orchestrate this. So everything is scheduled that Azure Data Factory starts the training, and Azure Data Factory also provides input for the AI and takes care of the output. But it's very neat to use an Azure function for wrapping the AI, I would say. Yes. But again, it could very easily be run on a local computer like this one. Like a container, you can start it in 1 second and use it. So that's very neat. And then finally, there's this web application. I will not dive too much into details here, but Azure Web Apps. So it's just a regular Azure Web App. Let's see if I can find it. Here it is. See. And if we look at configuration here, there's also some scaling and cost here. So we are running it on which level? What do you think?
Free.
The free one, yes, which gives us 60 minutes of CPU time each day. And this is actually 60 minutes. It's not that bad because it only consumes seconds when it processes the request. So, I mean, I've been using it quite a bit today, and if you look at the quota here somewhere, you will see I only used 0.38 minutes of the quota today. So 60 minutes, that's not at all bad for something you want to do, if you want to do proof of concept. And the memory is no problems. So it's good. But of course, in production, you wouldn't run anything on this free level.
You can do basic, but the basic has a lower SLA, and
yes.
the reason I would do basic is for
yeah, you would use something like standard.
And I would use custom domains and SSL. So
yes. So
I'd rather not put it in Azure websites.net.
No. But it's good for proof of concept. What I think is very cool, probably most of you have seen it already, but I think this console is very cool. So you can connect and you get like a old DOS prompt, command prompt to your web server.
Only if you run it in Windows.
Yes, but if you run it on a Linux machine, you get SSH instead. And bash prompt. So you can do like in Windows, you can check your files and everything here. But it's a bit limited, so I think if you want to do like format disk or something like that, it will not allow you to do that. So you have restricted rights. So that's it. And the app itself, it's written in, we used Visual Studio to write it. So it's just a regular ASP.NET Core web app. Yeah, it's very easy to deploy it. We just, just right-click, publish, and click here. So it's very nice to work, I would say, with work with Azure from end to end. So it's all, as I said, 100% running in Azure. Any questions? Yes?
You said that you're going to show the monthly cost for the total solution.
Yes, okay, yeah, I shouldn't forget that. So do we have a guess on the monthly? So we can say the daily cost, and a guess on the daily cost for running this.
Under 10 kronor.
110.
No, under 10.
Under 10.
Yeah.
Okay. Yeah. Let's take a look.
You run only this solution on this subscription?
Yes.
Okay.
We're almost.
Okay.
So.
$20 maybe, I would say.
Yeah. So let's see. Group by resource here. Yeah, you can see some days it gets higher, and this is because we did a lot of machine learning training and used a lot of CPU resources. But if you look at the standard cost every day, it's around 20 something. So that's
Cool.
yeah.
What is the light blue one?
The light blue one. That's a very good question. It's Azure Data Factory.
Okay.
That's
So
the most expensive.
That's the most expensive part, and it is because we run it quite a lot. We run it every 15 minutes to get data from SMHI.
So you could probably do some functions on that and cut down the...
Yes, we could probably do that. Yeah. So yeah, there's probably room. I think probably you could run this at under 10 kronor per day if you really wanted to. But yeah, it would be a bit inconvenient, that kind of solutions. Yes.
The cost of the work needed to
build
on another would be much higher. So you could probably run it for years for the cost that
Yes.
it takes to build a cheap.
Sure.
So if we could go back to the problem statement and predicted outcome,
Yes.
or what the solution was intended to solve.
Yes.
Could we go back to that and show?
Yes, I think it's time for me to hand over now to Magnus to
Yes,
finish the presentation. But if you have any questions about Azure technical things, I think we should take them now first. So do we have any more like Azure questions?
I have on
Yes.
the data lake,
Hmm?
you only had raw store, or do you do any processing and add it to another folder in the data lake?
We have raw store in the data lake, and then when it is processed, it gets stored in the SQL database.
Yeah, so you store it directly in the SQL?
Yes, so that is why there is no other level. So if in the data lake there is, if you look at the containers here, it is raw, and there's prediction, which is for the AI. That's the input and output for the AI and the model. But after raw, it gets always sent to the SQL database.
Yeah, so
In other cases, in other kind of data, maybe we could be interesting to have some processing in the data lake. But right now, it's we don't do any processing inside it. We take data from raw here, and then we transfer it. We process it and transfer it to the SQL database. Any more questions? Okay, so it's time I hand over to Magnus, who will come up with the conclusions. Yes.
So I realized before I never presented myself. So maybe I should do that. Magnus Lindhe, working for the city as product owner, product manager for IoT, open data and AI. So part of this project was to train an algorithm. The other part was to try out Azure's different tools and parts to build a data factory. So what happens now in the municipality? We will try to take the hobby factory, the proof of concept, into a citywide data factory. We're going to evaluate the proof of concept, which part has been successful, which part we need to twist a little bit. We will also interview other municipalities of how they think in this question of building a data factory, and also discuss with AI Sweden also. So we already have a decision within the city to during 2021 have a citywide data factory in place, so that the different departments can start working with the data in a similar way. But this is of course a very time-consuming activity. So in parallel we're running a project that we call Smarter City Lab, which is sort of a mini data factory and an AI lab, so that we can work both with internal data and external data to very quick try and test something. So it's more like a test bed for AI activities. So any questions? No? Then we have a break. We have some food on the other side here for those of you that